Okay, so the first observation to make is that we have a fraction and we have lots of radicals. We've got to try to simplify this before we're going to make any progress on integrating. So you'll notice that in the denominator, you just have one term, and that's very exciting for us because when we have one term in the denominator, we can split it up. So that is going to be our first step. Before we integrate, we're going to say, okay, I have x square root of x over x squared plus the square root of x over x squared, and then the dx. All right, now by splitting it up, we get rid of this big fraction, and we split it up into two separate ones, but we still have these radicals. So we will rewrite the radicals as 2x to the 1/2 power, and then reduce from there. So if I rewrite this square root of x as x to the 1/2 power, I'm going to have an x times an x to the 1/2. So that numerator is really going to leave us with x to the 3/2 over x squared. Plus, in the second term, if I rewrite the radical, I have x to the 1/2 over x squared. Now, by rewriting the radicals, we now have everything as x to a power. So we will reduce this by subtracting our exponents. So we'll take 3/2 minus 2. And again, for the minus 2, we'll have to get a common denominator. So I'm taking the 3/2 exponent minus the 2 exponent. So I multiply this by 2 over 2 for the common denominator, and I get 3/2 minus 4 over 2, which will give us negative 1/2. So that is x to the negative 1/2 plus, and then for the second term, I will get a common, or I will subtract my exponents by taking 1/2 minus 2, again, getting a common denominator here, and that will give us 1/2 minus 4 over 2, which gives us negative 3/2. So this will give us x to the negative 3/2. And again, we have not integrated yet, so we still have the integral, we still have the dx. So all of those three steps there, those are simply a simplification to get us in the posture in order to be able to integrate. So now that we have x to a number, we can use our power rule for integration. So what I would do is I would add 1 to the exponent. And remember, as soon as you start using the power rule, you lose the whole integral dx. So I add 1, negative 1/2 plus 1 is going to give us 1/2 divided by the new exponent of 1/2. Plus, then I take my negative 3/2, add 1. So when I add 1, I have 2 over 2, and that gives us negative 1/2. So we get x to the negative 1/2 divided by negative 1/2, and then plus c, and we're adding the plus c because we do not have bounds on the integral. All right, so our next step is with all these fractions in the denominator, we are going to flip those. So if I flip 1/2, I get 2x to the 1/2 plus, and if I flip negative 1/2, I get negative 2 over 1, x to the negative 1/2, and then plus c. Now, of course, to get to your final answer, you have to kind of look at the answer choices, look at what's going on over here, and you notice all of the answer choices have square roots. So we will rewrite all this x to the 1/2 as square root of x minus 2, and then our negative 1/2 we will rewrite as a square root in the denominator because of the negative exponent, and then plus c. And once you rewrite it, then you'll see an answer choice that is somewhat similar. But either of these are acceptable. A lot, again, is just trying to match it up to that correct answer choice.